A normal force is a support force. It acts when an object is in contact with a surface. A box kept on the floor. The floor is a surface and the box or the object is in contact with that surface. So the box will experience a normal force. You need to know two important things about normal force. Number one, normal force acts normal or perpendicular to the surface. And number two, the normal force acts away from the surface. In this situation, force mg will act downward and the normal force, let's talk about this word normal. In mathematics, the word normal is used to describe two lines that are perpendicular or at 90 degrees to each other. Normal force, as obvious from the name, will act perpendicular or normal to the surface. mg is acting downward and this is your surface. Perpendicular to the surface is this line. So the force of normal will act along this line and away from the surface. This is your surface. Going up is away from the surface. Going down is towards the surface. We want this. So this is the direction of normal force and not this. So along this perpendicular line, the normal force is acting upward like this. For an inclined surface, you have the object. Let's assume the angle is theta. mg will act downward as always. This is your surface. Normal or perpendicular to the surface would be this line. So the normal force will act away or in this direction. Along this direction, the component of mg would be mg cos theta. You will use this free body diagram in the coming classes. An object hanging from a string or a rope. If it's hanging freely in the air, it's not in contact with any surface, so it will not have any normal force. You have a wall and you are pushing a book against the wall. The wall is a surface and the book is in contact with the surface, so there will be a normal force. The normal force will be perpendicular to the surface. This is your surface and the perpendicular direction is this. So the normal force will be perpendicular away from the surface. Away means it has to go in this direction. So this is the direction of your normal force. And here, of course, mg will act downward as always. Let's come back to the first situation. Here we have Fn and mg. When we write the free body diagram or the force equation, this is the free body diagram done already. The force equation, sum of all the forces in y would be 0 because the box is in equilibrium. We know that y is positive going upward and it's negative going downward. Fn is upward, so it would be plus. mg is downward, so it would be written with a minus sign. The force equation is Fn minus mg equals 0. Isolate Fn, it is equal to mg. Now let's see what happens when an additional force is applied. We have mg downward, we have Fn upward, and a force F applied upward. We write the force equation again in the y direction, and we are doing y direction because all the forces you see here, they are all acting in the y direction. This is y direction, y, negative y. They are all in y. the equation would be F plus Fn. Notice that they are both pointing upward, so they are written with a plus sign, and mg is acting downward, so it is written with a minus sign. From here, when you isolate for Fn, you get mg minus F. Compare this with the original situation. Notice that Fn in this case is now mg minus of the new force that was applied. Compared to the first case, the value of Fn has decreased. Mg, now it is mg minus F. Fn has decreased. So we can say that when an additional force acting upward is applied, then the value of normal force will decrease. Consider this situation. Mg downward, force normal upward, apply a force F acting downward. Can you find what happens to the normal force? Will it increase or decrease from this original situation? Write your answer in the comments below.